Good morning, good afternoon, and good evening, everyone. GSEF is very delighted to welcome all the participants and speakers for the webinar on artificial intelligence and robotics in power sector. I will give a brief introduction about GSEF. Global Smart Energy Federation, which was jointly launched by US Department of Energy and Gridwise Alliance, USA in 2010 as a not-for-profit association registered in Washington, D.C. GSEF, formerly known as Global Smart Grid Federation, is a global stakeholder organization committed to creating smarter, cleaner electrical systems around the world and is comprised of national smart grid associations, forward-looking utilities, and think tanks from around the globe working in the energy transition and clean transportation. Members of GSEF include smart grid associations from France, Japan, EDSO, Europe, South Africa, South Korea, Caribbean islands, India, Indonesia, and Ireland, and forward-looking utilities such as ESCOM, South Africa, TNB, Malaysia, BPC, Botswana, and global think tanks such as Electric Power Research Institute, EPRI, Global Business Green Business Certification Incorporation, GBCI, Florence School of Regulations, FSR, and Texas State University, etc. The operations and work environment of electric and other utilities have drastically changed during the past few years. There is a greater need for power utilities to use advanced automation, robotics, and artificial intelligence to handle day-to-day operations. AI and other technologies will enable more efficient and effective operations by helping to analyze the massive amounts of data gathered from the digital devices. AI also has the potential to manage power flows in real time that will be required for the grid of the future. With this background, we will start with our webinar, and I would quickly like to take you through the agenda for today. We will be having the welcome address by Mr. Reggie Kumar Pillai, Chairman GSEF, followed by the theme setting by Dr. Amit Kumar Pandey, co-founder Being AI Limited. We'll be having the panel discussion with our moderator, Mr. Ravi Sitapati, and in speakers, we'll be having Mr. Nick Singh from ESCOM, Mr. Lawrence Schmidt from Decibel Europe, Mr. Davide Coppola from ESA Space Solutions, Mr. Sumit Gupta from Asset Plus India, Mr. Jayant Balaji from MathWorks, Mr. Thomas Lacroix from Cosmotech. After the panel discussion, we'll be having a Q&A session and closing remarks and vote of thanks by Dr. Pandey. Before starting the session, I would like to request all the participants to kindly keep your microphones on mute and keep your video off during the webinar. And participants can post their questions in the chat box. We'll be compiling all the questions and we'll be addressing them in the end. So without any further ado, I would like to welcome Mr. Reggie Kumar Pillai, Chairman, Global Smart Energy Federation and President, India Smart Grid Forum, for the welcome address. Mr. Pillai has over 4 decades of experience in the electricity sector in diverse functions covering the entire value chain across continents. Over to you, sir.
Good morning, good afternoon, good evening, and thank you very much for all the participants and our panelists, distinguished panelists. The importance of artificial intelligence, machine learning, and other related technologies need not be emphasized. Everybody understand, because today in every walks of life, all operations are being run by these technologies. The latest phrase I heard is AI plus X. X means artificial intelligence plus energy, or artificial intelligence plus health, artificial intelligence plus education, which means artificial intelligence tools applied to different sectors, and that is going to enrich each of these sectors as well as the artificial intelligence tools itself. So this is going to help each other in the development, and the tools will become more and more powerful, and the sectors will become more and more efficient. And the space is growing so fast. For example, as recent, we've been using for natural language processing, we've been using deep learning algorithms like RNN, the LSTM, GRU, etc. These are being now replaced by transformers. The transformers have come into effect only 5 years ago. The DeepMind or Google introduced transformer only in 2017, and which can do massive parallel programming, and transformers are now even come into from NLP, almost completely overtaken by transformers, and now it is coming into computer vision. Even CNN is being replaced. So these are all very fast changing. Every week, every month, things, new technologies are being introduced. I don't know how many of you have heard of AlphaFold. The example which I have told about AI plus a specific sector. AlphaFold is one sector where a AI system developed by DeepMind, it is actually predicting the protein 3D structure from a amino acid sequence. It is as accurate as the real experiments. And just imagine AlphaFold kind of uh, technologies being applied for energy sector, for energy prediction, energy usage, all that. The entire domain is going to change. And these are all going to be even more faster with quantum computing becoming a reality, and that is being commercialized very soon. So without taking much of your time, you have a very excellent panel of experts here, and a very warm welcome to all of you. And I hand over to the moderator. Thank you very much.
Thank you so
Over
much, sir, for addressing the audience on the various technologies and potential of artificial intelligence. Now, I would like to invite Dr. Amit Kumar Pandey for the theme introduction. Dr. Pandey is co-founder, Being AI Limited, and head of working group on AI and robotics, GSEF. He is also founder Socians AI and Robotics France. Dr. Pandey has also served as the President, Chief Science Officer, and Chief Technology Officer of Hanson Robotics. Over to you, sir.
Can you hear me now?
Yes, sir.
Okay, that's good. Okay, so let me start quickly. I hope my screen is visible.
We can see the presentation, sir.
That's great. Okay, so thanks again for this opportunity to again present some interesting aspects of robotics and AI in power sector, and thanks for joining all of you. So basically, I will just try to give a overview, and then we will already have very interesting panel and speakers who will be giving more insights and detail about different potentials and applications of this sector. So let us start with a ecosystem perspective. So we can see that there are robots which are capable of acting and interacting with the environment, and then there is IoT, which is basically giving the sensing capability to different robots, and then we have AI, which is basically we can see as the capability which is needed for decision making and planning. So from this perspective, what we can see is that now we have a body, mind, and sensors. So what we can do once we have all these ingredients together? The potential is enormous. We have to really figure out the right kind of application and the applications which are sustainable. And for that, we need to discover that what are the real needs and real requirements from different sectors, including the power sectors, as well as in different regions of the world. So never in the history there have been so much technologies coming together and creating something interesting, as Reggie was already saying. So it is really a new era of technology where AI, robots, IoT, all are coming together and combining other aspects like big data, blockchain, AR, VR, drones, machine vision, machine to machine communication. So all these are now coming together, and that's where we are exploring some new ways of integrating these technologies in the societies and for different sectors, which was not possible earlier. So I simply wanted to give the bigger perspective and idea that It's really a time where so many technologies are coming together, which was not the case earlier. And once they are really coming together, the potential is enormous, because they can help in reducing the workload. They can even supplement our abilities. More importantly, they can reduce the safety risk and dangers, and even help in reducing some errors from the human. And they can obviously find a way to improve the efficiency of the ecosystem. They can handle large amount of data, and they can find hidden patterns and useful information, and they can even predict situation in advance, which is also useful for predictive maintenance or reducing some future damages or dangers. And they are obviously making things more interactive, information rich, and ability to perceive environment. And they are also facilitating remote sensing and creating better connected ecosystem. So when I say they, I am not saying either robots or either AI or either any other technology, but the combination of this technology resulting in a particular solution. And what are those they? We will listen again in the rest of the session. So one of the aspect is they can really handle routine tasks, and allowing people to focus more on critical tasks, and then to be more creative for handling the aspects where more human attention is needed. And once we will talk about smart sensors, they are also becoming AI powered, and they are becoming smaller in size, more connected, and less expensive. And that is also helping in the whole ecosystem, in the improving the whole performance of the system. Again, I will not go in detail, but there are some pointers to explore further in this dimension. So once we will come back to robots, they can be teleoperated, or they can be semi-autonomous, or they can be autonomous. What does it mean? Like in teleoperated manner, someone is using the robot as the body to perform a task at remote location. In semi-autonomous manner, robot can take a small decision or a subset of decision by itself in a particular situation, and then rest of the decision will be taken by the human. And in a completely autonomous manner, robot is working autonomously for a particular task in a particular location to achieve the goal. And so again, depending on the need, we can have different levels of autonomy and intelligence of the robot as well. So there are several applications in which these technologies are already getting used, including inspection, cleaning, and maintenance, which is helping in having more precision or remote reach or efficiency in performance or safety, and also having availability 24/7. There are applications where we are also using robots for remote sensing and monitoring. Then there are robots which are used at the manufacturing facilities, even for optimizing even the structure. And combining AR, VR, and AI technologies, some of the new trends are also including how to train staffs through digital twin, and enabling staffs to visit virtually in a substation, move around the environment in the substation, and practice some operational and control kind of task. And obviously, then we need some interfaces to face with a customer or with operator, and there again different conversational AI technologies, which Reggie was also saying, is also now becoming the part of the complete offering or the solution. So with this, once we have robots and AI and cloud and everything is connected, we have to also consider the security aspects, including the cyber security. So there are also several initiatives in this domain, which I will not again go in detail, but this is also important to keep in mind, that we have to consider the safety security aspect once the technology is getting more integrated in the critical infrastructure. So there is a bigger ecosystem which should be built, and there are several aspects. I already mentioned about security, safety, but there are ethical, legal, social aspect. Then how the collaborative ecosystem should be there, regulations, benchmarking, evaluation, privacy, and transparency of the AI system, as well as the funding mechanism. And all these should be coming together, including the insurance sector, so that a system cannot be only seen as a proof of concept system, but it can be also used for the real application in a sustainable manner. And we will have a discussion around this also in our today's session. So the idea is obviously to create a smarter, safer ecosystem which can reduce the risk factor, have a higher efficiency, facilitate remote operation, have more predictive maintenance, and then why not to help in addressing environmental issues to be more sustainable. So with this, I think I can stop here so that we will go. Yes, this part is also interesting. So we have launched a white paper highlighting some of the applications, challenges, and the future directions of robotics and AI in this domain. So we will encourage you to follow that and even send us your feedback and remarks for improving or having newer version in the future. Okay, so let me directly jump to this part where I think we already got the introduction. So we have a very nice panel and very experienced moderator who has already contributed in the domain very much. So the idea here is that let us utilize this time and also learn from the experts and then think about just at least one innovative application of robots and AI in this ecosystem. If at the end of this session, if each of us is able to think about at least one application, even it is at conceptual level or a wish list, that will be good for us. And feel free to share that wish list or application even in the chat bot or separately, so that we will think that okay, what else or what all we can do by combining this technology and bringing in this application sector. So thanks again, and I will give the stage back to the moderator. Thank you.
Thank you, sir, for the theme presentation explaining the various aspects, modes, and applications of AI and robotics. We'll be now moving forward with our panel discussion, and I would like to welcome our moderator, Mr. Ravi Sitapati. With over 35 years of experience in energy and power systems, Sir is Executive Chairman by Cirrus Incorporations Canada, Corporate Director at L&T Power Transmission and Distribution, and GSEF Ambassador for Americas. So over to you, sir.
Thank you. Thank you. Thank you all, Reggie, Dr. Pandey. A very, very interesting subject. Just for bringing the introduction, I think Dr. Pandey had a very good overview of how things are already happening in three buckets. And the mind, as he calls it, is what is bringing this together. The power of data manipulation. To be able to take data from various sources, integrated with the environment, and then be able to come up with some kind of a decision process. Now, in the energy sector, just to bring some examples, we are already using a lot of these technologies that Dr. Pandey talked about. For example, we do all the transmission line monitoring with drones to look for defects along the line and also at the various tower heads. So that is one. We use drones today in nuclear power to send drones in when we think it's not safe enough in the nuclear area. For example, we have done that in Canada many times, where the drone will go in at certain specific, robot will go in and will take pictures of readings just to ensure that human beings are safe to go. And so that's an example Dr. Pandey brought about. In one of the EPC companies board I sit in, we already use virtual reality for every substation design that we do around the world. So we must have done hundreds. So the BIMS area, the whole area of substation design is already there, very, very clear, with the virtual reality being an essential tool, such that there are no problems on site at that time. And last but certainly not the least, when he talks of sensors, In our EPC business, we have hundreds literally of large earth moving equipments. Every one of them is fitted with sensors, with talks of return on assets to the headquarters, saying which machine is being used, which machines can be used, which machine is used for what purposes, what are the appropriate machines to be used for which work. All that is already being done to be improving the productivity and the downtime of various staff members. So with that, let me then begin to bring the panel to opening. The way we have agreed in principle in this format was each of the speakers get about 3 to 5 minutes. They may choose to use a slide or so, but bulk of them may just speak from their experience. And the second is I've asked them 3 questions. I know, Dr. Pandey, you asked for 1. I have asked for 3. Any 3 practical implementation they see coming, if not today, at least in the near future. What are the challenges they think they will face? What are the collaborations that will require to be done in order to see that through? And then what are the benefits they see in 3 areas? Either a benefit in the climate change area, in terms of operating equipment at high ambient, for example, or in flood situations, or in hurricanes, or snow situations. And the second is what would they also see by way of improved productivity for those in the utilities? The workforce is a very expensive workforce with tools, and therefore we need to see improvement in productivity. And the third, or not necessarily not the least, is will it lower costs? Would it lower costs in terms of doing maintenance? Would it lower costs in terms of doing construction, or lower cost in terms of doing engineering? So the oyster is the word for them to talk about, and I will let each one of them speak the first 3 to 5 minutes, and I'm going in the same order in which the brochure is. So I have the fortune of my colleague at GSEF and a good friend of mine, Nick Singh. You get the floor first.
Thank you, Chair. Thank you for this opportunity. I think, I'm trying to reserve my time to 5 minutes because this is such a passionate topic that we can talk hours on this. So I think, first of all, I head up the Smart Grid Center of Excellence. And you can imagine being smart grids, you're looking at everything from the customer, to distribution, all the way generation, and the entire value chain. So smart grid focuses on the future state of your electrical grid, which obviously now encompasses basically all the moving parts. And by default, as we move towards a smarter grid, the vulnerabilities of cyber attacks becomes more prominent as we get more digitalized. And that's the heart and soul of. Sorry, there's somebody who's not muted. Could you just mute them, please? Sorry, guys. Could you guys just mute? Thank you. Okay. So so I think as we move towards a fully digitalized future state, my focus right now, and I think I think my colleagues know about it, is Eskom's now moving towards a just energy transition, looking at how we encompass renewables more onto our network. So planning for this renewable energy and integrating them, right, both for the short, medium, and long term, are crucial to make this happen. And one of the ways to doing this is by deploying smart microgrids. Now that encompasses all the things that we are talking about today in terms of self-healing networks, data analytics. How do you take information and how do you take data and turn it into information? So data analytics and decision learning, decision making obviously is now going to incorporate a whole of machine learning, AI tools. We use TensorFlow and we use a lot of other algorithms to achieve this. But at the end of the day, the more advanced we get, we need to now be able to safeguard our staff accordingly. So as we can become more prone to cyber attacks, and you can imagine a recloser that's being attacked, and you have staff working on the line, thinking that this is off, So these are the kind of things that we need to safeguard against. So as we move more digitalized, I think the risks are going to get higher, and we need to get smarter, right? One of the key challenges, Chair, that I see right now is the level of skill as we move into this digital revolution. So, I think IT, OT, and the bridge between IT and OT systems, and having smart grid engineers that can now, jump on either side of that fence is crucial to functioning in this new future. In terms of the benefits that you asked, in terms of the three areas, I think climate change is the biggest topic right now. Unless we can turn around our carbon footprints and with all the aspirations of net zero by 2050, that is an extremely, extremely difficult target ahead of us. So whilst we're doing this, and if we can use these tools such as machine learning and analytics, so that we can forecast how we optimally place these renewable generators on our network, right? And hence saving time and money, right? And doing it safely. That's going to be core and crucial. So I think, Chair, we can open it up to the floor later on if there's any other areas that we need to talk about. But I'll be guided by you. Thank you, Chair.
Thank you, Nick. Thank you for that overview of the perspective. Next, we have Laurent Schmidt. I don't know, Laurent, are you there?
Yes, I'm here.
Yeah,
Hello.
thanks. The floor is yours.
Yes, thank you for inviting us to this discussion. So we are going to speak. I'm going to speak of a certain kind of robot and AI, which is actually hanging on the wall of homes. And so our focus is really on making sure we maximize the integration of electrical vehicle and solar PV into home environments. And so here that really relates to connecting the edge of the energy system with grid operators, especially TSOs and DSOs, so that basically this edge of the system, which is also an edge IoT device, dynamically interact with the energy system, so that basically the car can be used as a storage unit when there is a surplus of PV, as an example, or basically that the home can dynamically trade into intraday market grid auxiliary services and everything which the grid needs to stabilize. So that these applications are really using at large scale first the edge intelligence. So you see here the typical hardware which we're going to push on the market, which is actually an integrated inverter for both charging the car and the PV. But it also embeds quad-core CPUs, which is capable of running AI at the edge of the system, of forecasting the home loads, on optimizing the charging, discharging in view of electricity cost, but also gaining revenue from grid operator because it's participating into auxiliary service markets. So that will have a significant impact into the system. We think that, as an example, in Europe, we have set ourselves the ambitions to multiply the amount of renewable integrated into our energy system by 4, so going 4 times faster than before. That's what we need to reach net zero by 2050. So that means that we'll have almost no time to build grids. So that means we'll need to live with the grid as it is today, more or less, and we need to really be smart in the way we manage this integration through digital and data. We think there is a significant potential because basically solar coming on the roof of homes or buildings is the easiest way to deploy renewable, and it's also renewable which automatically gets self-consumed by the local users of the system, so it minimizes the usage of the grid. So overall, we think we will be able in the next 10 years, if we work successfully to deploy that kind of system over 40 million homes in Europe, similar in the US. And if we would deploy this on 40 million homes, that would save 280 million tons of CO2 per year just for Europe. So that is really a significant effort into carbon reduction. So this is really, in the same time, accelerating onto renewable integration into grids, minimize the grid reinforcement because this is very expensive for society in general, and basically turning every consumer-prosumer as an actor into the energy system through the usage of its car with bidirectional charging, or standalone batteries. So that's really a new approach where AI and edge IoT are a critical component to move forward. Very happy to further exchange on this as part of the discussion.
Thank you, Laura, for your kind thoughts. Next, we would have David Coppola. Your opening remarks, please.
And good afternoon, good evening, everyone. Thank you very much for inviting us. I'm Davide Coppola from the European Space Agency. To start with, I would like to give a very brief introduction about the European Space Agency and why we are involved into the energy sector. The European Space Agency is an intergovernmental organization consisting of 22 member states, and our mandate is to support exploration and use of space technologies for exclusively civil purposes only. We are organized across different areas. The team I belong to deals with what we call downstream space applications. So in a nutshell, these are applications of space technologies and data, such as satellite connectivity, satellite navigation, or Earth observation data, just to mention some example, with a mission to basically deliver services, applications that could be used in daily operations. So our objective is primarily to support socioeconomic benefit, leverage the use of space data. Now, back to the topic of energy. Since several years, we have been cooperating with stakeholders from the energy sector, and actually we launched our very first initiative a couple of years ago, which involved EDSO, but also Global Smart Grid Federation amongst the players. And the first topic we started with was indeed exploring basically the utilization of space technology and space data for smart grid, covering topics such as prediction and of generation peaks, but also using Internet of Things services for smart homes and electric vehicles, as well as asset management, just to mention a couple of examples. So I'm very happy to say that this initiative developed very much since we started, and now we are currently finalizing the last pilots with some companies in Europe that have developed these services solution addressing the requirements that have been basically brought forward by the stakeholders, by the energy stakeholders, which were involved by ESA. So since then, we've been working a lot and helping companies actually developing space-based applications in the areas of renewable. For instance, going back to one of the topics that was mentioned before, an area which has been historically very, very interesting for space application is the identification of areas for the deployment of renewable energy, let it be solar or wind, for instance. These are domains for which space data is available. There are usually a set of historical data that can be used to make informed decisions as to where to invest and install renewable energy solutions and plants. So renewable energy definitely is one of the most important parts of our portfolio, but we've been similarly working a lot in the area of digitalization and connectivity, as well as asset management. Where do we go next? Speaking about opportunities. So in general, we see that there are important trends which will benefit from the integration of digitalization, satellite connectivity, and space data. And just to mention 4 examples, electric vehicles is one of the topics where we think the role of space technologies in relation to integration of electric vehicles into the grid will be a major asset. Green hydrogen is another area which we see opportunities. Each sector decarbonization is the third domain, and the fourth and important one in the context of smart grid is the integration of advanced batteries and also looking at the recycling. We see that these are domains where space can really help delivering a new dimension of solution that can deliver social and economic impact, can deliver also environmental benefits, and we already have some examples of projects we have supported in the area of decommissioning of energy assets that, according to companies' estimate, can reduce the carbon footprint by 85% in relation to the use of uncrewed maritime systems for the decommissioning of offshore solutions. This is just an example, but similarly we see benefits across all other areas of energy. So the challenges, and briefly on this, we think it was mentioned before, there is an issue of market scale, and there is an issue of scalability in general, commercial scalability to bring this solution to an appropriate level of utilization. And there is an element connected to this of international cooperation across the energy players, but also the organizations such as us and others that are basically running framework to support the acceleration of solutions for the energy sector. And I'm more than open to and happy to answer any other questions in relation to how we see the market evolving, which kind of role ESA will be playing in the next years. Thank you.
Thank you, David. We next have Mr. Sumit Gupta. The floor is yours.
Thank you, Ravi. And thanks for inviting me to speak on this forum. So typically, what we are trying to address on the problems which are around the meter. And if you look at India, government of India has moved on a massive initiative of bringing out 250 million smart meters into the arena. And along with that, we have even 4 times more than that of the non-smart meters. If the environment has to coexist, how we can make it more and more conducive that we have energy theft reductions, how we can look in terms of there's an improvement in the billing, cash flow maintenance, and also the problems of where there are non-smart meters, can they all be coexist? So typically in the environment, when you look at, there's a revamped distribution sector scheme in India, which is driven from the center and looking at bringing down the loss levels of the different utilities in the state. We are working with one of the state over here, and there's an initiative driven by Ministry of Power, wherein under the scheme of revamped distribution sector, how AI and machine learning can actually improve in bring down the loss levels in these in the states. And a typical example comes in that we don't have any area, in fact, globally, if you look around, not even single country which is completely smart metered, or we can say there's no smart meter. And come to the part of India, we have an existence of where there are smart meters and there are non-smart meters. In such a cases, how can we look at that we are able to look at energy audit being done properly? We are looking at part of the pilferage points being detected properly, and also the billing. So that is what, as an Asset Plus Consulting, we are involved with one of the states and bring an AI interventions of in the smart meters arena, where there are urban influxes of controlling where there were earlier the energy audit was a problem, the dynamic network modeling was a problem. Now with the inclusion of smart meters in those areas, there is a complete energy flow can be looked around, and that's what we are doing. And with that, we are now able to dynamically look around who are those consumers on the DT or on the feeder which have a kind of a deviation of energy behaviors. And this brings in together a power of events and the consumption correlation with an advanced modeling algorithms to be used. But once we work on a concept which is at the meter and after the meter. So at the meter, I may have a smart meters where I'm able to catch hold of a person to look at what his behaviors are. But what about the people who are non-smart meters? How they have to be looked around. And therein we bring in an edge device. With that device, you are able to convert a non-smart meters into a smart meter functioning, and the data can be moved around. And that device can work on to fetch the information of each and every element which you are not able to do earlier. And if even the UP does not have a budget to go for that, we bring in a AI intervention where the existing meter reader who goes there, they can bring a non-permissive data wherein the readings and information can be captured there itself, and the billing can be improved. So now the whole purpose of when the more about the billings meter reading has been done, we can make the consumer more and more bill. And when the billing has been done, the next aspect is how to basically improve the cash flow. How we're able to look into these consumers, basically being part of that, they are able to bring my revenue to the utility. And that's where we work on that cycle of 2 weeks after the billing, when the bill has been generated, every utility has a problem that they do 100% billing, 100% collection. But this collection is being done after the due date. 1 month after due date, you find that 40-50% collection there. Now that's where utilities start working on the time within the before the due dates, and they look at predicting the behavior of those consumers, which bucket they are lying after the due date, which slab they are lying, because utilities have different slabs of the consumption where they are giving the subsidy, and the buckets are within a day. And then the predicted behavior with advanced algorithms are able to tell of where they're lying, and they could drive the methodology campaign to bring them before due date. When you do this, there is a revenue shift. Those which are lying outside the due date is now coming in within the due date and giving you the utility a propensity to have a larger cash flow, and also which is the interest amount which was not being looked around. That's what you're able to look at it, and you're able to drive it to the consumer as an incentive for making the payment beforehand. This is being done into the Indian context for the private utilities as well as for the government utilities. Today, government wants to look at how this environment can coexist, because this is a case, at least at the time we go for the whole stage of smart meters being brought into the ecosystems, and with the smart meters being coming up, and with the more accuracy of the reading, we are able to look at what aspect, what Raviji was mentioning around that productivity. Certainly the productivity will be enhanced, and we'll have a lower cost of operations, but the turnaround time will be higher for the people, and that will try to bring in a much more better cost of operations. So I'll just park myself over here, and we'll look over where the questions comes on my way later during the discussion round. Thank you.
Okay, thank you, Sumit. Next we have Jayant Balaji. Jayant, the floor is yours.
Thank you, sir. And once again, thanks for inviting me in the very prestigious panel. So I'm Jayant. I'm from MathWorks. For the people who are hearing MathWorks for the first time, it's a tool company, and we support tools for engineers across multiple industry segments. And energy sector is obviously one of the key industry segment where we support tools in multiple application areas. So coming to the topic of interest today, where AI can be applied, as many panel members and moderators discussed about that, electric infrastructure is an enormous ecosystem, right? Which is already generating enormous amount of data. And for just to take a near simple example, just which are the application that can be quickly adopted for my biggest take would be use data in two important aspects. One is primarily focusing on how the operations can be optimized, like kind of energy forecasting and resource shedding and things like that. On the other application, which I would be very much interested in, is kind of asset maintenance. Many of them also talked about predictive maintenance applications of various devices and various assets that is being attached to the electric grid. But when it comes to adopting AI, as many of them know, most of the time, AI is kind of a black box, and having a appropriate validation is critical. So before implementing into any AI system, right? So validating a model is a crucial step, and it's one of the challenging factor when it comes to adapting AI. And before taking into the deployment of end system, for example, here in this case, it will be like electric infrastructure. So if you're not validating the model and taking directly to the deployment phase, it will be a little catastrophic, because we are talking about a huge cyber physical infrastructure. And if any small mistakes that has been introduced by this black box model will be highly catastrophic. So most of the time, tackling this challenge, we hear about the model explainability, interpretability, and all those things. But also having the simulation model of the entire infrastructure, kind of a virtual model or a simulation clone, things like that, that makes more effective to validate your correctness of your AI model before putting into the application, such as operation optimization or predictive maintenance and things like that. That's what coming from a tool company, the multiple tools such as MATLAB and Simulink can help you to model the entire infrastructure, where you can plug in your AI models and you can able to validate the model for its correctness before taking into the final deployment. And you can thoroughly rule out all the uncertainties, reading the adversarial inputs or having the fault tolerant mechanisms, and without affecting the actual grid itself. So that is one of the key aspects. And validation is a key area where you can able to think. And obviously, like once you operationalize, it's a huge cyber physical systems where you can find like it will be very challenging to have it operationalizing as well as having the security aspect of it. So those are the challenges we want to overcome. But once we overcome this challenge, it can implement or it can adapt multiple benefits, like such as it improves the productivity. So we know the how to operate the AI models, how to improve the productions, and as well as it lowers the input cost. Like for example, like once you know which are the instruments to be operated or which are the assets to be operated, so it will bring down the low input cost, and you start shedding the number of resources that is operating. Obviously, it will have a greater impact on climatic change as well. So these are the high level take for me, and I'll give back to you, Ravi sir, for the next discussions.
Thank you. Thank you. The last panel member right now for his opening remarks will be Thomas Lacroix. Thomas, the floor is yours.
Very much. And thank you very much for inviting me to participate. So I'm Thomas Lacroix, I'm the CTO of Cosmotech. Cosmotech is a vendor that is offering B2B platform for simulation and digital twin that gives you the capability to test scenario and predict the impact of consequence before they rise. I'm also participating to the Think Smart Grid Association that is collaborating with the Indian Smart Grid as well. And we have recently published an interesting paper on AI that goes through as well the use cases, the challenges, and recommendation as well on that. So coming back to our topic, if you look at how electrical grids today are managed, I think we all agree that grids are some of the most complex systems that humans have been designing and operating over the last years. And we have been optimizing them through virtualization of the grid by being able to simulate the physical grid in itself to optimize the flow. And the operators have done that for many years now. But what we have been seeing over the last years as well, and the other members have been mentioning that, is decarbonation, energy transition, scarcity of resources as well, aging assets. They are driving the need to go beyond the physical part of the grid in terms of virtualization. And to go further in terms of automation and to embed as well resiliency in the way we automate the grid, there is a need to be able to simulate beyond the physical grid, simulate as well the ecosystem as it is, and as interacting as well with the customers, with the producers, and this virtual grid in itself, augmented with the ecosystem, can be considered as a sort of metaverse of the industry. And with that, we can go further in terms of AI model training and using them for safer automation as well. So if we look at how digital twins have been used as well, and what is the value chain of digital twins, we can see that there are three levels of maturity. The first one is using digital twins to describe as it is. So measuring through sensors, the grids, measuring through sensors as well, all the automation part of the grid. And that's a very good way to understand where you are and get alerts and potential problems. And beyond that, we see that you need as well to get some understanding on what is going to happen. So what are going to happen in the next 15 minutes, 8 hours, in terms of production, in terms of variation, in terms of loads as well. And as I said earlier, you can easily predict flows at the physical level, but when you start to integrate all the distributed energy, but as well the various new intelligent system, smart home, and so on that are connected, you need to go beyond that to be able to predict by having a more holistic view on the simulation. in order to be able to prescribe the right decision, the right control of the grid, and to orchestrate those scenarios through automation up to the edge part. We see three really critical capabilities to be able to implement it. The first one is really to be able to go beyond the physical grid and be able to represent the full ecosystem. The second one is to be able to test some scenario, real-world scenario, and the third one is to be able to orchestrate those analytics, including those smart automation algorithms that we talk about today. If I may introduce a few application use cases we've been seeing in Europe, so operators such as TENET, transmission system operator, Group E, distribution system operator, but as well RT in France, transmission system operator. We have been seeing them adopting a really novel and dynamic way of managing their planning of their maintenance, being able to maintenance and renewals, be able to replan as quickly and efficiently as possible the various operations under constraints. And we plan them even when you have some event arriving that's modifying your outage planning, for example. And by adopting novel ways of I will say, virtualizing the grid, virtualizing the maintenance of the grid, virtualizing the operations, all the skills of the people, those operators are being able to reduce their cost of maintenance, their cost of renewals as well, but as well the efficiency of planning, having more robust operations planning at any time, any place. Thank you.
Thank you all. So before we open up the question, I'm just going to quickly summarize. I think very, very interesting points from every panel member. The first is the notion of AI being a horizontal. You can see that where all AI goes is actually just the limit of the imagination. People have talked in various aspects, even outside of energy, and how to link the outside with the energy world. Something that smart grid started some 15 years ago, but now I think we are seeing the true benefits that we can integrate it. So AI being the horizontal. The second is we had, Nick talk about energy access. It's a very big question around the world today is the successful operation of microgrids. The more we talk of microgrid in its standalone and in its grid operated mode, the better we will be as a society to be able to say we are resilient. In fact, in New York alone, we are talking of how to black start parts of the city using renewable, which is, basically just an inverter-based devices. So the question is that the load that it will have to manage will be far lower when you're doing a black start till with such time parts of the city can be brought up. So I would like you to think about how to use every inverter, as Laurent mentioned, to be able to get that boost so that we are not thinking of synchronous generators everywhere. So that is this one. Second, Laurent talked about a very important aspect is the blurring of the divisions between TSO and DSO. We have had this subject being discussed for the last 7 years here, where the DSO actually feeds the TSO at night because of the reverse power that flows from distribution transmission. And the second important point he makes is that the grid will never be able to catch up. We have to manage with the assets we have if we want to go the renewable energy way, for which Nick talked about, the biggest impact being climate change. So then we had David, and he talked about space. In fact, there are some very interesting space applications which have largely touched the agricultural side so far. But we need to bring it. For example, when I was on the various committees, when I was on the utility, I would always say that wind turbines are always cascaded, flow-throughs. So you would have a wind pattern that comes from somewhere. We know that half a day later, it will go and hit this particular patch. And then another half a day later, that turbulent wind will go and hit another patch. It may become, what we call cascaded. So we don't know, even though we model it as independent based on some geographic dispersion, I'm not sure it's quite that much. And this could be said for cloud cover as well. And I think David touched on some of those aspects, how to bring it in. Sumit talked about basically how do we integrate the so-called regular meter with the smart meter? And it's not going to be that everybody is going to go to smart meter necessarily within the next 2 years. Many parts of the world are still sitting with the regular, I call it regular old meters. I don't call them dumb. They're requisitely smart for whatever they were intended when they were installed. But the question is, how do you integrate it and how do you improve the customer choice, the customer basically expectations, and the revenue expectations as well. So we talked about how do you get that hybrid model. Jan talked about the tools, and I can tell you on the tool side, I wish I had a comment for him. Data generation today is actually exploded. It is not exploding, it is exploded. I can easily generate 100,000 data points every minute if I have to from one asset. 40,000 thermal measurements we get, in fact, in every minute from one asset alone in one of our projects. So the question is, how do you parse that as you move upstream such that the essence is drawn out and then the tool works on the essence alone as opposed to trying to manage all these billions and billions of data points. So that would be one sort of challenge. And I think Jayanth touched on that. And last, Thomas talked about the digital twin. It's just coming up. Many sort of advanced utilities have already started the digital twin. We have, in fact, several here. But the digital twin, in my view, has not been leveraged. It's not being leveraged simply because it takes only electrical parameters and does certain dynamic modeling. It does not include the non-electrical parameter like the thermal parameter, the weather parameter, the forecast parameter very well. And so you have a digital twin that I think is still not fully optimized. So with that, sort of connection between all, I'm going to open it up for questions. And if there are no questions, I have a few questions on the panelists themselves. So Parul, over to you.
Thank you so much, sir. We have a few questions actually, and we have compiled them. So I request.
Speak a little louder.
Am I audible now, sir?
Yeah.
Okay, so sir, we have a few questions actually by the audience, and we have compiled them in a presentation. We'll be just quickly sharing our screen for that, sir. So I request my colleague Tanyata, she can share the presentation.
I see some of the questions are directed to the speakers themselves. Others are open-ended, so maybe I may throw it up or pin one of you to answer those questions.
Sure, sir. I think that will be more suitable.
So do you need more time or you're okay with the questions?
So I think we can go with the questions themselves, or I can read them out for you.
No, it's up to you. I leave that whole part to you. If you have a question on the stage, people can all see. Whereas if you speak to it, sometimes, it gets missed. But I'll leave it to you. I'll leave it to you.
Okay, so sir, we'll just share our screen. Just give us a moment, sir.
Okay. So maybe while that is going on, I think there's some typing going on in the back, and so we need to give them time. So I have a question for all of you. Is there any point that another speaker made that you either agree or disagree with? The floor is yours, all of you.
Maybe I can start if you want. This is Laurent.
Yeah, sure, please.
Okay, so I would like to come back on, I think, on the point of Thomas. This was this point on this digital twin, and I think that is very true. And so I've been working a lot in my life on control room environments. So that's true that grid operators are using state estimation and a lot of simulation historically, but really the complexity now is to move beyond the edge of the system and being able to model into a digital twin, end-to-end interaction, orchestration across the value chain. especially in an environment where electrical vehicle is going to bring flexibility into every home. So we did a simulation in Europe that potentially the entire pan-European energy system could get balanced only by flexibility in the future from buildings and homes. So I think this is a very fundamental, crucial point to progress in the future. I could also respond to a few of the questions on electrical vehicle in a separate response.
Yeah, well, when the questions come up, we'll let you do that, Laurent. Any other rebuttals or agreements or disagreements from any of the panels about the other panelists' thoughts?
Yeah,
I
Chair,
have
it's
a
me. Oh,
point to actually discuss with Nick on that. How in the ecosystem where ISCOM and Africa has been a way ahead on using smart prepaid meters earlier, and they were to control to certain extent about the problems of postpaid meters and reading collections. But how in ESCOM are you today looking at the prepaid system which has been there? Has it been very effective? And how do you look at the intervention of smart meters coming up over there in your ecosystems and helping you reduction the loss and accurate reading which is there?
Okay. Yeah, through you, Chair. The prepaid metering system is purely, just a type of meter. So it can still be smart. So the policy within ESCOM is that every meter will be a smart meter, and that smart meter can be configured either as postpaid or prepaid. So even the prepaid systems that are being deployed, right, are smart meters. Okay, so that's the policy that we've adopted throughout the country to ensure that that we future-proofed. That even on a prepaid system, right, you could have customers with renewable integration and electric vehicles that can play a part. So the stance was to use smart meters, irrespective whether it's prepaid or postpaid.
Anybody else commenting on another panelist's
Thank
view?
you, Nick. Thank you. That's very helpful.
Okay. Anybody else before we turn it over?
Sorry.
Yeah, I have basically it's neither a question nor a disagreement, neither an agreement. But I happen to be one of the technical advisors for this RDSS project for a particular state in India. Well, I would just like to compliment Mr. Gupta, Mr. Sumit Gupta on this, that apart from we are talking of electrical vehicles, we are talking of renewable energies and everything. But if you look at RDSS project and also the initiative that is being taken by the Ministry of Transport for using hydrogen as an alternative fuel, there I think at the end of the day, a clash I think will be coming up till we take a holistic view of that how to integrate this energy also in the power sector.
Okay.
So, but RDSS project actually does not include that. That's number one. Number two is another big issue in this RDSS project is we are talking of from the distribution point of view, but especially the government utilities has to go through a large process of modernization to actually take the benefits of this smart metering project. This is what I feel.
Thank you. We've heard you, so I think in the discussions, hopefully we'll bring it up. And you're right. Both your comments are valid, and we hope to hopefully at least have a discussion or a follow-up if some of the panel members would like to bring in. So at this time, Parul, why don't you post the questions and let's take them one by one.
Sure, sir.
Okay, the first question is, how can we set up a smart grid or integration of renewables with non-smart meters? Anybody wants to take that? By
Yeah, I did actually respond to that question in the chat. So
okay.
yeah, so I can talk about it.
Yeah.
I see smart meters as your edge devices. right? So that's the point between the utility and the customer. If you don't want to have the smartiness or the smartification happening there, then it needs to happen somewhere else. So, uh, my colleague spoke about smart inverters and the smart chargers. So that could sit at that point. But at the end of the day, you need some sort of IoT device that will be able to give that information back. And the question is, where do you put that, right? And when it comes to smart meters, it's very rarely the case whether the smart meter is more expensive than the non-smart meter. It more is involved in the installation of that meter. That's what we've seen. You know, the cost of the meters between smart and non-smart is negligible. You will still need to install it, and getting into the customer's domain, you know, and accessibility of it, etc. That's what where the challenge normally comes in, at least from my perspective. Okay, thank you.
Just to further that, about 12 years ago, before smart meters were very prevalent and smart inverters were there, we actually put that smart control on the load side with an autonomous setting, which is in percentages. So as you cross 70%, your non-critical loads will start getting tripped. And as you approach 90%, you know, all your non-critical loads get tripped. And that was like a kind of a very, call it a dumb way of doing it. And but that's just because the smartness was not there at the point of interconnection. So just to answer your question, Ms. Beatty, I think it is possible. The question is, what are the best solutions? And there will always be a payoff for that solution that you put in. So next question, please. Keep the questions up. Keep the questions up so that everybody can keep reading it. Okay, the second question is from Surik Mukherjee. It says, has there been any actual implementation of blockchain technology in tariff metering? If yes, please share. Actually, we have a guru in our panel, but let me open it up to the panel first, and then we'll talk about that. Anybody on the panel wants to take this about blockchain technology being implemented for tariff metering? Okay, if none, Reggie, are you there? Okay, Reggie is also not there. You know where it has been actually implemented with reasonable success has been in India, thanks to the effort of India Smart Grid Forum. The India Smart Grid Forum has done actually, in my view, pioneering work with the utility, with practical application, using blockchain technology, in fact. And I don't believe anywhere else it's been done in that kind of a full envelope type of implementation. It is small, but nevertheless, it's a full implementation, a 360 implementation of the blockchain technology, including metering. So I hope, Sarik, that answers it. Next question is, how should a utility start its AI journey? Oh, this is a big one. So who would like to take that? Laura, I'm going to throw this over to you. Your previous gig actually probably had lots of these consultations. Are you here, Laura?
Yes. So is the question is for me?
Yeah, I was thinking because in your previous life you just dealt with this with customers.
Yeah. And we still have a lot of interaction with utilities wishing to use our edge device and improve the quality of their scheduling and dispatch, making use of bidirectional charging and self generation. I think what is important is, first of all, not to start with a business critical processes. And I think one of the other panelists was mentioning about this risk of being business critical AI. Of course, this risk exists, but all processes are not business critical. And I think it's very important to start on processes which are kind of optimization layer, where basically mistakes or errors which you have in your AI calculation does not imply a significant risk to the system. So what we've been seeing as best practices, as for instance in Belgium, in Europe, Elia, the TSO, is really leading the journey, I think, when it comes to that kind of approach, where they set up a data sandpit where they invited a lot of players through the ecosystem. So they created a bridge with the ecosystem. So they recognize that their substation is not the only thing to look at, is to go beyond their substation, and they really enabled new services, especially around fast frequency response and making use of sub-metering, data from edge IoT, going around the metering, the smart meter of the DSO, for the purpose of improving the quality of their frequency response, as an example. So I think it's a good practice that first you need to isolate some non-critical data in your control room environment, create an ecosystem around this data sandpit, and then basically work and learn from this experience, and recognize that the first calculation won't be right, but you're going to learn by doing, in a way.
Thank you, Laurent. The next question is a long one. I'll read it quickly. Is could you please help us with an example of AI implementation in system operations in India? Load dispatch centers dealing with a lot of data, and they have to generate various energy accounts for stakeholders. Now, since Reggie is not there, I'm going to take this on, knowing India a little bit. It is done already. In fact, just to give you a scale, India has got about 140,000 megawatts of renewable on its grid. It's approaching 50%. So in other words, of the 280,000, which is their so-called total, about almost 50% is being achieved. But that is not in the entire country, right? There are parts of it that have got excess renewables, such as west, southwest, southeast, and east. So the grid, in fact, POSOCO, as it manages the 4 regional grids, if you will, and India is an island, right? Let me also tell you, its neighbors, links to its neighbors, unlike Europe, is actually very, very poor, much like probably, many other places. So the question is, it has managed this island, if you will, with a very high penetration of renewables very successfully on its transmission. So when you talk of energy account for stakeholders, it is the transmission accounts that I can really talk about. The distribution accounts, which largely the panelists are talking today, is wanting. It's wanting in very, very many places around the world. So, the system operators in many places, as you know, do not see right into the distribution system. They only see it up to a certain point, and then they count on the DSOs to manage it downstream. So if I can answer your question that way, perhaps it'll serve better for your understanding. So the next question is there any use case in the world where AI is being used in demand response? So I'm going to throw it open to the panel.
Chair, within it's Nick. So within the my microgrid, containerized microgrids that are rural, completely off-grid systems, right? We would need to do forecasting and predictions in terms of working out how the customer's load's going to be, especially in an off-grid system, which is extremely difficult to do. So there's a whole lot of forecasting, weather data services that comes through, and it looks at the state of the battery as well as what the load is, and it does a on the fly setting on the load limit to accommodate the respective load, right? So I think it's a combination of load limiting, forecasting, and a little bit of machine learning to look at previous trends. And we've been doing that for quite a while now, since 2016. And it's proving to be very, very accurate. And the system basically learns. It learns from its previous states, and then it gets smarter and more accurate as it moves forward. So most definitely there are applications of that or use cases where this has been done. Thank you.
Thank you, Nick. The next question from Kirti Konal is how technology helps utilities to basically manage a huge demand of electrical vehicles. I think the question is, if we have a large penetration of electric vehicles, how will that huge demand be managed? I'm assuming hopefully through technology and AI. So I don't know, Thomas, do you want to take that on?
I can give a first response, and that's
sure.
That's exactly what we are trying to do with our home energy station as an example. And that's what we want to use is the vehicle not as only as a vehicle, but as a battery, and basically making it as a resource to the grid to stabilize and potentially to become more resilient, creating a microgrid in the home environment. And that's a good example of basically trying to think beyond pure grid reinforcement in using the flexibility of the battery of the car to support the system. Of course, the challenge here is the valuation of that flexibility, is the remuneration. How can we compensate for certain way of using the car? I think we see EVs coming now majorly with bidirectional charging capability. So we need to put together the right business model to enable this to happen and avoid unnecessary grid reinforcement.
Thank you. Thomas, do you have anything to add?
No, I think it's pretty aligned with what Laurent just said.
Okay, thank you. We move on to the next one, and this is from Subhashish Dash. How AI helps in managing reactive power injection due to increases in EV vehicle charging station. I'm going to take this on over and above EV. The question that's being answered by the utilities and the utility code is, can these smart devices manage voltage? Up until very recent time, it was a no-no that voltages could only be managed by the utility, and they are very poor at it, particularly in the grid edge. So, but in some of the OEM technical panels that have been involved as a mentor, we have got devices that actually can inject inject reactive power, PCC, from the smart inverter, such that the nodal voltage at the point of common coupling doesn't go down. So in other words, every house, if you will now, becomes an autonomous voltage maintainer. And that technology exists today. Where the problem is actually with the utility grid code, because many of the utility grid codes will not allow you to control voltages. It is their prerogative by historical reasons, and that is being fought. But a lot of the changes in the various 1547s and others, this has already been talked about, has been standardized, and many of these vendors now actually give you that. For example, in one residential one that we have here, you can inject 500 VARs per second as a ramp to very quickly correct that voltage dip. And so it even protects you from short circuits should there be a unlimited short circuit feeling at the point of common coupling. So this technology has gone way ahead of the grid code. The question is, how will the grid code now allow these technologies to function as a part of the utility system? Next question. We have from Dr. Mohammed Khurshid Akhtar. He says, what are the risks and challenges using AI in power sector? Are awareness of all stakeholders regarding benefits of AI necessary, or tech leadership can implement it without the knowledge of all stakeholders? Now, this is a policy question. Who wants to take this on? Okay, there you go, Laura.
Yeah, so I think that is largely discussed in Europe right now, and in the view of all the ethical discussion which we have around AI, but also in view of the consent and privacy management. I think what we really see, and we heard it from Nick as well, that there is a good chance for improving forecasting and so on. And using sub-metering data, that means that these are data which are owned by consumers, and which are tightly related to their lifestyle and so on. And I think there are risks about these models being misused in certain environments and basically unprotecting the privacy of consumers. So that's where, in our case, we've been extremely careful on this privacy and cybersecurity. And we've encrypted basically everything from the hardware and edge up to the cloud. And I think that's going to become a very serious requirement in the future, as mandated now by IEEE 2037-5.
Thank you, Laurent. Yes, I fully agree. Just to let Dr. Akhtar, in fact, I sit on the bio-digital convergence of the IEC committee. And I can tell you there it affects the human body, right? Because you're bringing AI and IoT into the medical side as it relates to the person. But one common denominator, if I can share my experiences, never bypass the stakeholders, no matter how dumb you consider them. Because I know it's a push pill, I know it is going to take more time, I know they may not have the level of knowledge that most of the scientific people have, but in the end, the society wins. The policy side will never move unless you have grabbed all these guys and at least educated them. I had to do that 14 years ago when the concept of smart grid was coming along in our utility. But you know what, painful as it may be, it is the right way to do is to involve the stakeholders in all your thoughts and your next steps, as opposed to saying the technology leadership alone will solve the society problems. So that's my 2 cents added to Laurent's talk. The next question is, can smart meter be smart enough to help consumers in terms of smart consumption of energy? Okay, who wants to take this now?
Yeah, Ravi, I'll take this answer, the question of Arun. Certainly, smart meters will not alone will help you to manage your consumption pattern and control. If you need to really know about that, then the signature pattern of your devices within the home, it comes from how your smart energy data is being given to you. So when you get the data of your home consumptions each block wise, and that data, if you are able to analyze and you look at how you are switching on and off any devices, so over a period of time, so 3 to 6 months, you can get to know which devices you are using, which devices you're not using, and that way you're able to understand the signature of your work and of your consumption. And that's where this will help you to really become more aware consumer on your smart meter data. So that's what how smart meter can help you. But yeah, it takes a little time to understand and then give it. There's a whole lot of data analytics around that to make it happen as a service. It can be provided to you to look at all the devices of what you're using in home.
Thank you, Sumit. Any other questions?
Can I just maybe add to that, please, Chair?
Sure.
I agree with you 100%. We looked at signatures of various appliances and trying to match them based on its energy signature. However, you would need to have smart meters that have the right resolution of data, running through it. So what we found out is that everybody wants to try to get it, done the most cost-effective way. So we love using G3 PLCM and all of these other bandwidths, but the bandwidth through that is so low that you cannot get to the point where you can achieve that, unfortunately. So I think we need to really think about the future of metering and what sort of bandwidth we actually do require to be able to do all of this fancy stuff. Thank you.
Nick, absolutely. In fact, in many, many cases, it is the telecom infrastructure that has become the limitation even 2 years out after implementation. So it's like building an airport, right? You think of what the airport should be and you build it twice its size, and then you still have passengers flowing through it and overflowing it. So it's one of those kinds of challenges. The next question is from Dr. Subhan Sharma. What are the recent trends of AI application in GIVs? I did not understand GIVs, but if any other panelist understands that, please answer.
Sir, this is Raji. This is grid integrated vehicles. That's the term we use for V2G of late. So it's very, AI is very, very important in GIV, smart charging of the vehicles, particularly when to charge, when to discharge, and also interacting with the market, the real-time market. At what price point the vehicle should be charged, at what price point it should be discharged, or how much it should be retained. So that activity cannot be done without some amount of artificial intelligence into it.
Right.
Thank you.
So I'm going to let Laurent add to that. I think he touched on it in his opening remarks, but Laurent, why don't you talk about that?
Yeah, that's absolutely true, and we see it in Europe, especially in the case of homes having photovoltaics together with the vehicle bidirectional charging and a battery. And what you very quickly realize is the traditional baselining and the forecasting which you get out of a smart meter is not meaning anything anymore, because the statistical behavior of an electrical vehicle charging and discharging has nothing to do with a population of other similar consumers, but has to do in the way you actually use your car, or basically the PV which you have over your home, which depends on weather data. So basically, that's where we are in Europe right now, is to rethink how to manage flexibility in the future, get away from baselining, make use of AI's specific approach, where basically what I think every car will in the future be able to self-schedule itself into the energy market using AI technology in view of what he knows is usage.
Right.
That's the future.
Thank you, Laurent. The very last question, and we are going to land this plane on time, I think. Can Indian discoms think about setting up smart meter endpoints for the consumers free of cost? Interesting. By utilizing AI, blockchain powered rewards, or consumer assessment. In other words, if I get the question, you're saying, can rebates and rewards actually pay for the meter itself such that it becomes free to the end consumer? Who would like to take that on?
No, see, in India, we are not charging anything directly from the customers. So the current program, which is there, 250 million smart meter being rolled out under the RDSS program, 15% of the capex is given as a grant by Government of India, and balance money is on an OPEX model. And the price has become so competitive today that about $1. This is exactly what in our white paper in 2017 we predicted, $1 per meter per month. So that time dollar was 68, 69 rupees. Now it's 82 rupees. So some of the states where they have already awarded millions of meters, the 10 years about 82 or 84 rupees per meter per month. Actual business benefit for the discom is much more than that. There are different, about 18 or 19 different benefits from the smart metering, not just AT&C loss reduction or the avoiding the manual intervention or something. There are so many other actually demand profiling, and also able to accurately estimate what is the today's demand and contract power according to that. That's where the power purchase cost optimization is one of the main advantage. And the smart meter data really fine grain the distribution grid. You have correct view of what asset where and etc. So that benefit is in the initially many of them did not understand that in the
Okay, thank you, Reggie. Okay,
the benefit of
Reggie, we are losing you. We are losing you. I think we have lost you. Okay, you know what? In the interest of time, let's move on. So any closing thoughts from any of our panelists before I hand it back to Dr. Pandey for his closing remarks? Good. Laura, you raised your hand.
Yes, so thank you. I think that was a very interesting discussion. Thanks for organizing it. One point which was really not touched was the issue of data interoperability. And I think what is going to be crucial is to unleash data in being able to train AI and make use of AI in different domains. And so that's where data structure, data spaces, and so on are getting very, very important, so that we don't end up into AI in a single vendor hands. And so that's where the European Commission is also doing a lot of work. Just published a new digital chapter for energy, where the concept is to digitize the infrastructure end to end, but really through interoperability and data sharing across actors. And I think that's a very important element to move forward into these new models.
Yeah,
Anything
Ravi, I completely agree with what Lauren mentioned, and also what Jayant also has touched upon, because today utility wants to pick up AI use cases, but to deliver those use cases, you need to have a data which has to be there, and the data has to come from every utility. As if you ask about 150 applications which are running on different sources, different data points, and then moving them into a centralized environment to run and give them the outcome, it's a complete value chain. And that value chain, security, data pushing, edge devices, and different protocols, interoperability. I think the biggest thing required is, as one question was, how utility can start the AI adoption, is awareness. The awareness about what needs to be done is first to look at what technology is required and what use case to pick up to see the flavor of it, and then taste the success and then move it around to next level. Today we start from a very high level of use cases wherein the data for that is not present. I mean that's what certain utilities will have good data, NIC will have good data at ESCOM, right? But certainly among the various other utilities, if you look at, still there's a problem to understand how the data. Now there's a question which came from Kriti Kunal saying that about can we have a data lake or putting a voltage together and then look at creating it as a centralized environment, a data lake, and then do a modeling. Looks good. When the first POSICO, they will have to do that part of it as a transco, as a ISO. But whether and what way it has to be configured and thought through, awareness and things. And I think sessions like this, ISG, the way it has been organizing, bringing together the various uh, speakers across the globe, this helps utilities to get an understanding about how they have to move in this direction. So thank you, ISGF, for giving us this opportunity to share our experience, what we're doing in India on the loss reduction, and also to understand about from the other
This is
speakers.
a GSEF webinar, not ISGF.
Sorry, GSEF, sorry.
Reggie wears two hats, so okay. Any other last parting words? We have about a minute left before I have to hand it over to Dr. Pandey, otherwise he's going to get me. Good. So I think, okay, that's a thumbs up. Okay, I thought Nick, you had a point. Okay, Reggie, I think the practice is what? To everybody to turn on their cameras, right? For a picture. Parul, is that what your protocol is?
Yes, sir. So
Yes, please.
before moving towards the vote of thanks, may I request all the speakers to turn on their cameras for a group picture? Um,
You can be on the thing as well. You are one of the members. Turn on your camera. So I guess we had a smile.
yes. Thank you so much.
Okay, thank you. So Dr. Pandey, the floor is yours to close the session.
Okay, thanks. I hope I am audible again. Okay. So I think it was very interesting and good learning experience for all of us. So thanks Rezi, Asima, Parul and the entire GSEF team for such initiative because this type of initiatives are very much needed and this gives an opportunity to everyone, all the stakeholders to understand new technology as well as discuss, exploit the potentials of such technology for different needs. So even I think the whole session during the discussion and panel discussion and then audience engagement, they were so interesting. And thanks Ravi ji for moderating this. And you very nicely mentioned that how the body, mind and sensors like robots, AI and IoTs are already working in a real setup. And that's very important because we have to understand from the not only from the theoretical perspective but also from the real deployment perspective that where and how this type of system can work and help us, and not only they are working separately but they are also working as a ecosystem and that's also very important to push the development in this direction. Then from speakers, I think from Nick, we understood the aspect of security, which is very important. Then Laura mentioned the plans and challenges for net geo, like what changes we can do and what are not feasible, provided a timeline we have set by ourselves as the community or as the decision makers. Then David talked about what lessons we can learn from a space sector. That was also very interesting. And then Sumit ji talked how to make meters smart and how to let them coexist with non-smart meters and where is the future. So that is again something important to see the practical deployment and the challenges and the all the milestones we have to achieve for those deployments. And then Jan talk about the importance and challenges of validation of model before real deployment, and that's also very important. It reduces lots of risk as well as it makes deployment faster. So we have to figure out how we can achieve those. And then from Thomas, we understood the importance of digital twin for optimization. And one interesting thing was, I think it is not only enough to simulate the grid, but also to simulate the entire ecosystem. And then we understand better that where are the challenges, the bottlenecks, the feasibilities, and how to address those in a phase-wise manner. I must also thank the audience, because it was so engaging and fantastic audience, because the questions were very grounded, and it was even provoking the thoughts for all of us, that where we are, what we are planning to achieve, and how we should be achieving those. And that's where I think it makes a successful webinar, when the audience engagement is so interesting that we even have to forget about the timing. So I think one interesting thing was also that perhaps for industry or for the sectors which are trying to incorporate new technologies, it is not necessary to make changes everywhere. We can select the sector, like the places where it is not very business critical, and try to start implementing or integrating technology there, and slowly make the migration. So there is nothing to worry or be scared that okay, everything will be changed or destroyed, or we don't know how things will move on if we will try to integrate or adopt to the new technology. So that was also very interesting feedback which we got through this audience engagement and the question answer session. So again, I think it was a great learning experience. We all learned, and then let us see that how the advancement of science and technology can go back to the people and also benefit all the stakeholders in the ecosystem. And this type of seminars and events will be a great important step towards that. So let us keep exploring the needs and potential. So with this, I will stop myself. I have many things to talk again, perhaps next time. So floor is back to Rezi.
Thank you very much for all the panelists and all the audience. And the presentations and the recording, WebEx recording link will be circulated by our team to all the registered participants in the next 2 days. And thank you very much to ISGF team, who is acting as the secretariat for GSEF and making this webinar possible. All the best, and stay safe, and look forward to seeing you all soon. Thank you.
Thank you.
Bye-bye.
Bye-bye. Thank you. Thanks all.
Thank you, everyone. Thank you.
Thank you. Bye-bye.